All right, everyone. I think we're about ready to begin. I want to say good morning and good afternoon to everyone on the East Coast. I want to thank everyone who's attending. We have another great turnout for our latest webinar in the NIMBL series, the top 10 tips to optimizing your BW environment. I'm Jake Eisbart, part of the NIMBL marketing team. A little bit about NIMBL. We are a fully onshore SAP company that handles production support. Let's get that slide up for you. Fully onshore company that handles production support, production consulting services, SOW production support, ERP, CRM development, security. And tomorrow we're actually having a in-house NIMBL-sponsored Halloween contest with the theme being Techie Zombie or Zombie Techies, however you'd like to categorize it. Here is a quick list of some of the services and support that we offer. Obviously, today we'll be focusing on BW. And here is a list of some of the customers that we've worked with and are currently working with. Just a couple of housekeeping issues. We want to be able to answer as many questions and comments that you have, so feel free to type them in the chat box at the bottom left, and we will respond to them at the end of the session. So let's start it up. Our speaker today is Marcelo Berger. Marcelo is a senior analytic consultant for NIMBL with a background in SAP BW and BOBJ with over 12 years of SAP BW experience. Marcelo has been involved in multiple support engagements and full lifecycle implementations across multi-billion-dollar organizations, cross-cultural teams, and several countries. Marcelo is a frequent blogger in the SAP community, and a little-known fact about Marcelo, his go-to karaoke song is Don't Stop Believin' by the band Journey. So now you know that. And with that, I'm going to hand it over to Marcelo. Marcelo, go ahead and take it away.
Thank you, Jake, for that introduction. So thank you all for joining on today's webinar on the top 10 tips for optimizing your BW environment. Had to come up with a list of only 10, but we really all know that there is a lot more that we can do to really fine-tune a BW environment. So let's get straight to it. So this is our agenda for today. We're going to go through the anatomy of an SAP Business Warehouse. We're going to look at the key pain points. As many of you already answered, it's mostly in your front end and slow reports and real-time data. So we'll go through those and a few other pain points that I have faced as well in my career, as seen others face. Why to performance tune? And then let's go into it and provide a few back-end tips and our front-end tips. So as Jake mentioned, I've been working with SAP BW for the past 12 years in either support or implementation capacities. I've managed in teams across the world. And these 10 tips, as you all know, they're not comprehensive. There are many more, but these are a few of them which have been very useful for me throughout my career. Some of them might seem obvious, but you'd be surprised to see how many of these are not implemented on BW environments. So let's move ahead and let's go through the anatomy of a business warehouse. So this applies mainly to BW 7.3 and before. It's based on SAP's LSA, which is your layered scalable architecture. You're probably all very familiar with this architecture and this setup, where we have at the very bottom our source system, so either SAP, ECC, or any other third-party tools, SQL databases and whatnot that connect, that we extract data and put it into our BW environment. So we have our extractors. We then have our PSA layer, which is automatically created. We usually model it with an inbound layer where we would have our DSOs, so our data store object, where we're now persisting data, and we can apply some ETL to it through our transformations. Depending how you structure your environment, we could have a second layer of DSOs for further ETL and applying business logic to it. We would then have our reporting layer, which would be our cubes, our info cubes, which is another layer of persistency where data is stored. And on top of that, if you're using best practices, we would have a multi-provider, and then your BEX query. On top of that, if you have another front-end layer, such as business objects, as many of you do, that is yet another layer that we need to create in order to support reporting for our users. So as we can see here, everywhere where we have the little yellow explosions, these are little areas where we need to touch. We as developers, we need to touch and change whenever a change is required, whenever something new is required, a new functionality. And everywhere where we have the white boxes, so the DSOs, the PSAs, the cubes, that's where data is stored, persisted. So we have a lot of redundancy in BW for many reasons, but those are a lot of layers which we need to manage. And finally, in the multi-provider and BEX, that's our virtual data. We don't actually store data there, but we need to properly model those to have great performance. So the three key areas here when we look at this anatomy and we think about performance tuning is really the modeling, if we're modeling correctly, how we're doing our ETL, as well as reporting. So those are the three main pillars in which we need to, as developers, we need to look at when addressing performance. So next section we will touch on the the key pain points for a developer and a user, and many times those overlap. The issues are common for both sets of users. From a developer perspective, long ETL times. What do I mean by that? We have our process chains. Typically in a BW environment, we schedule those to run overnight. We have that batch window, which ideally we want to complete before the start of the next business day. And depending on the architecture and how many millions of records we're loading, that can take anywhere from 1 hour to, who knows, 10, 12 hours. So that's typically a very huge pain point as a developer, making sure our process chains run, and they run efficiently, they complete in the allotted window that we have. And many times we have issues where we have large corporations, where we have users scattered across the globe, and people, or your business users, are showing up at different times of the day, and we need to make sure data is available to all of them in a timely manner. So that's a huge consideration to keep in mind. Time to deploy a change request. So as we all saw in the our anatomy or the architecture of BW in the previous slides, we can touch many objects when we need to make a change. So the simple example is if a user requests a standard field in a standard table to be added to a business objects report. It's a simple change, but we need to enhance the data source. We need to add that field to the DSO. We need to update the mapping and the transformation. We need to then add it to the cube, update the transformation, add it to the multi-provider, add it to the BEX query, finally map it to BOBJ. And again, it is a simple change, but it's time consuming. And then when all those changes are done, we still need to reload data in order to test it. And again, if we have long-running ETL process, if we need to reload a lot of history to test that change, that is another time-consuming, could be a very time-consuming effort to make a very simple change. And finally, as a developer, slow-running reports. So, as a developer, we want to make sure that our users are happy. We want to make sure that they are using the BW system. We want to make sure they are engaged, and they are, really stewards of the solution. So we want to make sure that the reports that we build run in a satisfactory time. Satisfactory time is a subjective concept. What I've seen in my experience is that typically any report that runs over 2 to 3 minutes starts to become a pain point for end users. I personally feel that 3 minutes is still a lot of time, but again, in my experience, users tend to disengage from the solution after beyond that 3-minute threshold. So now moving on to our end users, data availability. So many of you mentioned that you wanted real-time data. So as I mentioned before, typically we refresh data once a day, typically overnight, so that at the beginning of the business day, users have the latest data available. If we can improve our ETL processes or the run times of our process chains, that can give us opportunities to run those process chains multiple times a day and to give users more up-to-date data. And finally, slow running reports. That's typically what users look at. Again, if the report is running longer than that 2 to 3 minute threshold, that's when we start to see users disengage and not really, or they want to find alternative methods to getting their data. So the good thing is that all of these issues can be improved if we carry out performance tuning. So again, the next section, why performance tune? So really, we want to, as I mentioned before, we want to make sure users are engaged. They are they speak for the reporting solution. Many times I have had to come in and into a BW solution where we have users who simply don't trust, or they don't want to use the solution because it's too slow. It takes them 10 minutes or 20 minutes to get one report to run, and then they need to rerun it, and it takes another 20 minutes. So, that is performance tuning. It should always be a key consideration when building your data warehouse. So, the first thing here, future-proof your data warehouse. If you from the get-go build a solution which will perform well and will be easier and simpler to maintain, as well as more readily adaptable to change, you're going to be setting yourself up to success when building that data warehouse. You're going to make sure your users are engaged, they are actively participating, and actively involved in using the BW environment. You can also, typically BW's environments, up until HANA and now with the real-time replication, was really more for managerial reporting as opposed to operational. As we all know, it's very hard to get real-time data into our BW environments. So, with the advent of better performance as well as other replication techniques, we can have managerial reporting as well as operational reporting. As well, we can empower the developers to reduce their time to deploy. So again, if the BW system is nimbler to change, we can actually have changes implemented faster and get users to test them faster, because of now that we can load data faster and we can get them their reports quicker. That will make the developers more empowered, and it will also make your users more involved with the solution. And finally, the last bullet, which I kind of hammered throughout here, we will increase the user acceptance of the data warehouse. So we're going to get widespread adoption. People will be really keen and excited about using the BW environment. Okay, so now this takes us to we're going to start off giving our back-end tips for BW. So I've split this up in back-end and front-end. This is mainly for BW systems. A lot of this can be applied if you do have BW on HANA. But just keep in mind that this can be used for both BW on a traditional database as well as BW on a HANA database. And again, a lot of this you probably or you might have already implemented, but these are things that I have learned throughout my years. A lot of this is SAP's recommendations, and you'd be surprised the amount of companies that do not have best practices when they've implemented their BW environments. So let's start off with the first tip. This is around logical partitioning. So as the name suggests, this means splitting up your cube logically. So, the most typical that I have seen is we have one, for example, a sales cube, and it has 10 million records, 1 million records per year, for example. A good practice is to split this cube up by year, so you would have a 20, 10, 11, 13, and so forth, but each of them having only 1 million records in each. So I put this here as a back-end performance tip, but at the same time, this will improve your query performance, because if you have to run a report only for a single year, let's say for 2015, when you run that report, that BEX report or that Webby report, and you put your criteria in there just to look at 2015, instead of having to select data out of a single cube with 10 million records, it's going to look into only one cube for 2015 with 1 million records. So that select is going to be less costly, and in turn you're going to have faster running reports. As you see here in the presentation, we would still have the multi-provider on top, and that's where your BEX query would be created. So for the end user, this would be completely transparent, as you would have only a single BEX query, and the multi-provider would handle where to select the data from. So I mentioned fiscal year, but this can really be partitioned by any logical field, company code, or region. These are also other common fields by which we could do logically partition the info cubes. So moving along, second tip, batch jobs. So many times this is overlooked. Within our BW environment, and then within 7.0 and above, we have the DTPs from which we move data within BW, and we can set the number of batch jobs that we want each DTP to execute in parallel. Obviously, the more batch jobs in parallel, the faster the DTP will execute. The problem here is really understanding how many background jobs we have available in our BW environment, and at the same time analyzing our process chains to see how many parallel DTPs we have. So this is not an exact science, but it is something more of trial and error. So we have to go into the BW system and see, okay, we have 50 background jobs available. We have 3 DTPs running in parallel. Let's see if we can put maybe 9 background jobs for each DTP. What we really want to be careful is not to exceed the amount of background jobs that we allocate to DTPs, and then we don't cause an issue where we have bottlenecks and we run out of background jobs. So the other thing to keep in mind for batch jobs, we can have the scheduling where we change. We have a night schedule where we increase the number of background jobs, but then during the day we revert that, and we have more dialogue jobs for use for the BEX queries to run and for the users to run their reports. So that's another thing to also keep in mind. So the way we would do that in a DTP, it's really quite simple. We would go to the go-to menu, the settings for the batch manager, and then in the number of processes, that's where we would change the number of background jobs to a greater number, and it has to be a multiple of 3. So it would be 3, 6, 9, or 12. So typically what I've seen, again in my experience, it's okay, obviously depending on number of background jobs and process chains parallelization, but 9 to 12 seems to be an okay number, but this is something that has to be looked at each system individually. So tip number 3, this is the DTP data package size. So typically what we prefer would be a larger package size, since each package has an overhead associated to it when it is initialized. So if we have fewer data packages, we're going to have less overhead to initialize each of those data packages. So an example that I put here, let's say we're loading 50,000 records from the PSA to the DSO, and we change the package size to 1,000. So this means we're going to have 50 data packets, and we're going to have 50 overheads, one for each of those data packages, as opposed to if we have the package size of 50,000, we only have one overhead for that one package, and we're going to group all those records into that single data package. So this is the rule, the general rule. There are exceptions and considerations. So one of the main considerations here, this logic applies very well when we don't have any customization in the transformations. So we don't have any custom ABAP code to do any additional selects and to enhance the data. So that works pretty well. But when we do have those cases where we do need to do additional lookups into DSOs or master data, and we have to store that data in internal tables in our transformations, that's more of a trial and error to understand, if we're consuming all the available memory, if we're not expanding that internal table too much, and we end up getting a dump. So again, this is an iterative process. It's a lot of trial and error. There is no magic formula. It's really, each customer, each client has its own requirements and its own custom logic. So that's one thing that can be done to improve the loading performance of your DTPs. All right, tip number 4. So secondary indices on DSOs. This might seem obvious to the more experienced developers, but I have seen, again, cases where there are selects done in transformations on a DSO, and we're not using the key field of the DSO, and the customers complain of performance. So this is a very it's been there for a while, and it's a very simple change to make. If we have to do a lookup onto a DSO in a transformation and we're not using the key field, we can create a secondary index based on the fields that are being selected. So it's really quite simple. We really just go into the change mode of the DSO, go to the bottom where we have indexes. We would create a new index and assign the fields that we want as to be our secondary index, and activate the DSO, and there you have it. We will notice significant performance improvements once that has been done. So tip number 5. So now we're going to come in a little bit into the ABAP section. So again, as developers, we need to do a lot of customization in our ETL to augment or enhance the data per whatever business requirements we might have. So these are a few ABAP tips that I've learned along the way to really optimize your custom ABAP code when having to do those additional lookups. So the first one here is to use field symbols versus work areas. So pretty much what a field symbol is, it's really a pointer to an internal table, whereas when we use work areas, we're actually storing the value from that internal table in that work area. So the example here is if we do a loop on an internal table that has 100 records, the field symbol will store the position of each record through each pass of the loop, and then will allow us to modify that internal table. As opposed to the work area, it will actually store the record that was looped. So you can see right there that 100 records, they're very few records, but when we start talking about thousands and millions of records that we're looping through, there is a huge memory impact from using field symbols as opposed to work areas. And what I've noticed throughout my career is that we will have significantly better performance using field symbols. So here's pretty much just an example of how we would declare your field symbol in your ABAP. So first we declare the type. So we're having we're beginning with type, so begin of the internal table 1, and we're just using field 1 and field 2, and then we end that type. And then we just declare the field symbol, and we have the less than equal and greater than equal. That's where we encapsulate the name of the field symbol, and we declare it type TI tab 1. So it's really simple. And then when we actually perform a read, we use the assigning command. So here's the example. So we're going to read table itab 1 with the table key field 1 equals the results field 1, and then we assign the value that we read based on that key to our field symbol. The next thing we would do to make sure that we can go and process our custom logic is we need to validate if that field symbol was assigned. So we have a simple if statement if that field symbol is assigned. And then we're going to have the return code associated. So if we get a return code, an RC0, that means that yes, it is assigned, and the logic will be processed. If it's anything different, then it will go out of that if. And the key thing here is before we end our processing, if that field symbol is assigned, we need to unassign that field symbol. So we do that by putting the command unassign field symbol, and then we close our if statement. So that is, and then that was a read. We could also do a loop. So looping it's similar. We still have to use the assigning command. So we would loop at our source package, assigning source field. So in this case here, I'm just using an example of a start routine where the source field symbol is declared already by default by SAP. The real difference here between a loop and a read is that we do not need to unassign the field symbol. So pretty much at each iteration of the loop, it will unassign it and assign the next record in the loop to that field symbol. Okay, so then the next topic here, the next tip number 6, would be the parallel cursor. So not sure if you've all heard about parallel cursor, but this technique came about. Inevitably, we have to sometimes have nested loops. So what's a nested loop? It is a loop within a loop. So that's a big no-no in terms of best practices. So it can have huge performance degradation issues, especially when going through thousands and millions of records. So this is where we can use this little trick, which is called a parallel cursor. So what it comes down to is we start the loop in our first table, and we now need to start our loop in the second table. So before we start the loop in the second table, we do a read into that nested loop, which identifies the starting position of the record that needs to be fetched. So once that is identified, we then do a loop in the nested loop based on that position, on that index. So if we have our nested loop, which has 100 records, and the position that we need to fetch is in position 35. It's the 35th record. Rather than going through, okay, let's look at field number 1. Does it match? No. Field number 2. Does it match? No. And so forth. We are starting that second loop directly on that 35th position. And that saves us a tremendous amount of time. So then once we start that loop at the second loop in the nested loop, we then perform a check to validate if that nested loop is still valid. And we exit that nested loop if that loop is no longer valid. So if we go here to the next slide, this is an example here of how to actually code that in BW. So we're starting off, we have we have iTab 1, so our internal tab 1. That's our first loop. So we do that loop, and then we assign the field symbol. So here we're also using field symbols for performance. We then do the read into that internal table 2 with key field 1 equals the field 1 that's assigned to the field symbol from the first loop. And we assign the field symbol 2, which is the data that we found from iTab 2. We then do that check. If field symbol 2 is assigned, so that means that there is a valid record in our nested loop. So then we take the psi tabix, which is pretty much the index, the position, and we assign it to that LV index, and then we unassign the field symbol 2. We then start the nested loop into our iTab 2. We assign it to our field symbol 2 from the LV index. So we're starting that loop at that exact position that we need to start. And then we have our little check here at the bottom. So if our field symbol 1 is not equal to field symbol 2 and field 1, we exit. So we will only do the parallel cursor for as long as it is needed. So if we find that field, for example, in the first 5 records, or from the 35th record until the 40th record, and it no longer is valid, it's going to exit the nested loop, and it will proceed to the next record in internal table 1. So this is a very valuable piece of code. We have a very small example here which shows the performance improvement. It's very few records in the table that were used, but the performance improvements were 80 to 97%. So this is truly, I've used this a couple of times, and it truly is a time saver when we have these situations when we have to do loops within loops, or nested loops. So tip number 7, again around ABAP for BW. This is around hash tables. So the hash tables, it's really a simple concept. It's nothing more than tables that have a defined key, as opposed to we declaring a standard table, and then we have to perform sorts to sort it according to whatever criteria we need to carry out, and then we do the read with the binary search. So when we declare the data type, we declare the type exactly the same as we did previously, but then when we declare the data, we then say that iTab, our internal table 1, is type hash table of our type, TITAB1, and we declare the field as being unique. So we're saying here that with the unique key field 1. So, and then we have our field symbol declared. So hash tables are really good when we have a clear, unique key that we already select from whatever lookup that we're doing. And in terms, again, of performance, it will perform better. We don't have to do that additional sort command. So it will typically perform better than declaring the internal table as a standard table. So as I mentioned, when the data is selected, the hash will automatically be calculated, and the sorts in the binary search will not be required. So here at the very bottom we have an example of the statement of the hash table. So the only thing to keep in mind when we're doing a read of that internal table, which is hashed, is that we need to use the command with table key as opposed to with key. So that's really the main difference when we read data that has been loaded into an internal table, which is a hash table. All right, tip number 8, which is the master data lookup. So as of BW 7.0, because we as developers, we were doing a lot of lookups into master data. They introduced a very, very requested functionality, which was to easily read master data attributes, and we could do that directly in the transformation without using any coding. So that was a welcome change, and it really simplified a lot of the modeling and the coding. But what I've found in my previous experience again is that if we use custom code to select master data attributes during our transformation loads, those performed better than the standard method. So the way we do that is really simple. So we have a start routine where we select whatever fields we want from our master data. So here we're selecting field 1 and 2, and we're selecting from our P table from our master data. We're putting it into an internal table for all our entries in our source package, where the key that we need is our source package key, and we always want the active version. So once we do that, we'll have all that table in an internal table. If again we define our internal table as a hash table, we don't need to do a sort to sort the data. But if it's not a hash table, we would then have a command here to just sort that itab 1 according to whatever fields need to be sorted by, ascending or descending. And then in our field routine, we first do our check. So if the result fields is not blank, it's not initial, we then read our table, our internal table with table key. So we're assuming here this is a hash table, and then we assign the field or the value to our field symbol. If our field symbol is assigned, we then pass field 2 or whatever the attribute is to the results, and we unassign our field symbol. So it's a pretty straightforward routine. Again, in my experience, although there is standard functionality to do this, we've noticed that performance was better when using custom, which is counterintuitive, but that's really what we noticed. All right, so now I'll cover a few front-end tips. Let's get into it. So this is for BEX reports, so the selection of structure elements. So as you all know, we can come across requirements where we have to build a lot of restricted and calculated key figures. Sometimes we have to create a lot of them to support the final restricted and calculated key figures that need to be displayed. And sometimes all the restricted key figures and calculated key figures that are created are not made readily available to users. Sometimes they're hidden and they have to unhide them if they want to see additional information. So what the selection of structure elements gives us is for those scenarios where we have, for example, 10 restricted and calculated key figures that were created, but only 3 of them are being displayed in the standard report, but the user has the option to unhide the remaining 7, for example. If you check this little box, the BEX query will only calculate, when it's executed, those 3 restricted and calculated key figures that are being displayed, rather than calculating all of them, but only presenting those 3. So if you enable this checkbox, only that will happen. That will result in better performance because you have less overhead. You don't have to calculate 10 restricted and calculated key figures. You only have to calculate 3. And if the user so chooses to bring in additional key figures to view during the report execution, then those will be calculated once he refreshes the report. So this is another very nifty little trick. Not everyone knows about it. You can set it in RSRT for your queries. here are a few some BEX tips when using business objects. They also apply if you're only using BEX, but they can be used for both scenarios. And this is a little bit of a bonus section where I'm going to kind of bundle a few little tips into the 10th tip here for BW. So specifically, if you do have, and I saw many of you do have BW on HANA today, if you do have BW on HANA, you all know that a lot of the functionality in terms of data loading, as well as the OLAP, so the front end where a lot of the processing happens, a lot of that is being pushed down to the HANA database. So interestingly enough, this setting here, so the push down to the aggregation to the HANA database, this is not set to push down to HANA by default if you do have HANA. So when you have a lot of calculated key figures and restricted key figures, and you're doing exception aggregation and you're doing counts, that can be very onerous on the system, and it can make reports really take a long time to run. So this is a very simple change that you can do at the multi-provider level. So if you have many BEX queries that are built on that multi-provider and you make this change on the multi-provider, all of those queries will be positively impacted by having that pushdown sent to the HANA database. So really what you want to do is in the multi-provider, you go into your change mode. There is an options for multi-provider properties, and if we go here to this section where it says SAP HANA BW operations, it's typically going to be set to 0 by default, but we want to set it to 6, exception aggregation, and all that is telling us is to push down that OLAP functionality down to the HANA database and take advantage of the power of HANA. So in my case, we had reports that would literally take 5 to 10 minutes, and once we checked that, it went down to seconds. So it's a very simple change with huge impacts. A few other tips here, mainly for BEX. So free characteristics. Try to limit the amount of free characteristics that are available in your BEX query. Try to really use only those that we know the users might want to drag into the report. It's not best practice to make all the fields that are in the cube available as free characteristics. Likewise, we don't want to make all the fields or put a lot of fields in the rows section. We really only want to put what is really the key requirements of the end users. Suppress results. There is a big overhead that happens when we calculate results. I'm sure that for those of you who have created BEX queries and we've added a lot of characteristics into the rows and we forget that setting to remove the results, when we first run that report, we're going to see many levels at the very bottom of results by all the different characteristics that have been added. And it typically takes longer for that report to run when you have all those different levels of results. Likewise, for business objects, when you're using BEX as a source, you want to make sure that you are suppressing all the results because you're going to do your presentation at the BOBJ layer, and you're going to choose what you want to have as results and totaling and so forth. Calculated and restricted key figures. They can be very onerous. So we want to make sure that we're really only using the calculated and restricted key figure that are really required for the reports. For the case of business objects, we want to try, when we use BEX, we want to make sure that instead of using variables in business objects to do calculations, we push that down to BEX because BEX takes advantage of the HANA database, and the OLAP engine and processing in BW is significantly better than that in business objects. So when you're building your BOBJ reports and you have to create complex calculations within business objects, think about moving those down to the BEX level and taking advantage of BW there. And finally, BEX variables. So I have these little graphs here at the bottom. When we use filters in business objects, all the data from the cube is passed, and then only the data that is required and filtered in business objects is filtered in business objects, as opposed to if we create the variables in BEX, we're actually filtering the data that we're passing along into business objects. So as we can see here, we have all this data in the cube, but we apply that filter in the BEX query, so we're only sending that limited amount into BOBJ. So that's a best practice when we use BOBJ on top of BEX. And finally, a lot of these here are common sense. Users want a lot of data, but sometimes performance can be an issue. So apply filters. That's going to reduce the amount of data that's selected. That's going to result in faster report times, executions. Have inclusions rather than exclusions. So if you use an inclusion, it'll actually go against the statistics in the back end and will perform better than if you used exclusions. So wherever possible, try to use filter inclusions rather than exclusions. And then lastly, here, if you do have a lot of restricted key figures and calculated key figures and those reports are taking long to run, you might consider those as candidates to calculate during ETL and actually store them in the cube so that you don't have that overhead of processing when you run a report. It's actually calculated during the loading of data.
All right, I think we've reached the end of our Q&A. I want to thank Marcelo for joining us today. I hope the webinar was very informative to everybody. And again, thank everybody for joining us as well. I do want to talk about some up-and-coming, our up-and-coming November webinar, which we're really excited about, which is by our own Michael Pytel. It's going to be real-world ERP on HANA migration strategy, demystifying and removing fear. So that will be coming up, and everyone will be notified about that. As well as a couple of people asked about the recordings, whether or not you will get a copy of the slide deck and the audio. The answer is yes. We will be sending out the recordings to everybody. You can also find it at bnimble.com, which is our website. Feel free to take a look at that. And we will also have it on YouTube under NIMBL, NIMBL. So if I didn't mention, our website is bnimble, BENIMBL.com. You can feel free to take a look at some of the other projects we're working on, and again, the audio deck and the slide reel will be available as well. And if you have any questions for Marcelo, you can contact him directly at Marcelo Berger at bnimble.com. And I think that is about it. Again, I want to thank everybody. One last thing. At the end of this, you will be asked some poll questions and some comments. We definitely advise everybody to fill out the questions, answer the questions and the polls as well. And any comments you'd like to have, we would love to hear. And again, we hope everybody enjoyed, and have a great weekend and enjoy your Halloween. Thanks so much.